Hello everyone, we are from Group 4. My name is Lai Hong Yu.
Multi-layer perceptron neural network is a type of artificial neural network consists of multiple layers of interconnected artificial neurons. Each node is a basic processing unit that performs a weighted sum of its input and apply an activation function to produce an output. Convolution neural network is a specialized type of neural network designed for processing and analyzing structural grid-like data. It exploits the local connectivity and spatial hierarchy of visual data, enabling the network to learn hierarchical representation of increasing complexity. We have four objectives for this mini project. The first is to study and investigate the knowledge of multi-layer perceptron neural network and VGG-19 CNN model. The second is to interpret and discuss the result of MLP model and CNN model based on the various performance matrices. The third is to train a MLP model to classify dataset A and dataset B. The fourth is to train a CNN model to classify dataset B and compare the result of MLP model. Now I will talk about the methodology for question 1. The first step is to load and create the data in workspace. Both dataset A and dataset B are loaded into MATLAB and categorize them into 10 classes, and the target output of 10 times 100 matrix is generated. The second step is import data for training network. Predictors and responses are selected for training. We set the column of the predictors matrix and responses matrix to be a sample. The third step is to set the training parameter and train the network. We can adjust the percentage of validation data and test data and the number of neurons. The number of hidden layers need to be added in the comprehensive training script. The fourth step is to generate the comprehensive training script, and the fifth step is to test the network manually. The test for data A is to see whether the network can identify the random generated data into any class. The test for data B is to identify whether the network will classify data into correct class. The last step is to repeat the network training. In the first, we train the network with 1 hidden layer and 10 hidden neurons. The second case, we increase the number of neurons into 40. In the third case, we increase the number of hidden layers into 2.
This is the methodology for question 2. First, we need to convert the data to image. After that is generating and the loading of data. This part is to tell the model where we locate our database. After that, load pre-trained VGG-19 network. And next is the augmentation of image data. This is to increase the training data size, increase data diversity, mitigating overfitting, and robustness to variation. And this is the augmentation option that we can select. Then is specify the training parameter. In our model, the stochastic gradient descent with momentum are selected, so these are the training parameter that we can change. And 30% of our database are used for validation and testing. And finally is to train and test the model.
This is the result of the dataset A classification rate. Out of the different settings performed very well as classifier, overall, the higher the number of hidden neurons and hidden layers, the better the classification results. The classification of dataset B is slightly higher than dataset A at the same settings. For the network to be a good classifier, the cross entropy may need to be further reduced. We can see that it's slightly improved when compared to the classification rate and cross entropy from the network of 40 hidden neurons from a single hidden layer. 2 hidden layers and 40 hidden neurons have lower cross entropies and slightly higher classification rates.
This is our result for question 2. At first, this is our training parameter, and the maximum import is 20, and the validation accuracy and the testing accuracy is very low. So, we increase the maximum import while maintaining the other training parameter until the maximum import equal to 100, and we get the validation accuracy 90% and the testing accuracy is 100%. So, we decrease the initial learning rate to 0.001 while maintaining the other training parameter, and we get the validation accuracy 90% and the testing accuracy from 95% to 100%, which is good enough for our model. And this is our training progress for test 6. For our model, we set 20% of our database are used for testing. So these are the 20 randomly selected pictures from our database for you for testing, and each picture is predicted correctly. So the accuracy is 1, which means 100% correct.
In conclusion, multi-layer perceptron neural network perform very well in data classification, and multiple training iterations were conducted to improve their accuracy. The performance of the classifier is influenced by the number of hidden layers and neurons. The MLP network trained using MPR2 achieved a satisfactory result with an average classification rate higher than 90%. In the case of convolutional neural network, the one that we use is VGG-19 is highly effective for image processing tasks, and it leverages the convolutional layers to capture spatial hierarchies and local patterns in images, making them ideal for tasks that rely on spatial information. MLP and CNN achieve similar accuracy results, but CNNs are preferred for complicated image classification due to their ability to capture local translation invariants. That is all from us Group 4. Thank you very much.